In the last lecture, uh, we told that the apparent magnitude of a star depends on their intrinsic luminosity or intrinsic brightness and also on their distances from us. Since the distances are vary considerably, their apparent magnitude do not provide their actual brightness or actual luminosity. If therefore, if you know the actual distance of the star, we can compare their luminosities by referring them to any chosen distance from us where they are assumed to emit their light. That is, if we know the actual distance of the star, then if you are having two stars and we know the apparent magnitude and their actual distances, then we will compare their luminosities or brightnesses by referring them to any chosen distance from us where they are assumed to emit light. For such a comparison of luminosities of stars, astronomers have chosen a standard distance of 10 parsec, that is 32.6 light years. The magnitude of a star is then called the absolute magnitude. That means the absolute magnitude of a star has been defined as its apparent magnitude would be if it were placed at a distance of 10 parsec, and this 10 parsec is taken to be a standard distance. So, if you are having any star and you know the apparent magnitude of the star and its actual distance, then we will be able to calculate its apparent magnitude at a would be if it is placed at a distance of 10 parsec, then that magnitude, apparent magnitude, will be the absolute magnitude of the star. So, the absolute magnitude is the apparent magnitude would be if it were placed at a distance of standard distance of 10 parsec. Thus, the absolute magnitude m of a star has been defined as its apparent magnitude would be if it were placed at a standard distance of 10 parsec. The absolute magnitude of a star therefore depends on its absolute or intrinsic brightness and not on its actual distance from us, because in the case of absolute magnitude, it gives the absolute apparent magnitude at a distance of 10 parsec. That is, the brightness of the star when it is placed at a 10 parsec is the absolute magnitude of the star. So, it does not depend on its distance from us, because all distances are at a 10 parsec, and it will give the actual luminosity or absolute luminosity or intrinsic brightness of the star. Now, if you consider two stars, let small m be the apparent magnitude of one whose brightness is Bm and distance is d. That is, if you consider a star whose apparent magnitude is m and whose brightness is Bm and which is at a distance of small d. Now, for the second star, let us consider capital M be the apparent magnitude and Bn be the brightness, and which is at a distance of capital D. Here capital M represents actually the absolute magnitude, then this D will be 10 parsec. So, consider two stars one star is having an apparent magnitude small m, having brightness Bm and at a distance of d. Then the second star is having a magnitude m, brightness n and distance d. We have the relation Bm by Bn is equal to 10 raised to 0.4 n minus m, which we have derived in the last video. But brightness of a star is actually inversely proportional to the square of its distance. It is from the energy relation, because brightness means it is the luminosity. Luminosity means the energy emitted by a substance, and as distance increases it decreases, and it is inversely proportional to the distance. That is, if you consider the Bm, the brightness of the star m, then which will be proportional to 1 by d square, and Bn will be proportional to 1 by d square. So from these two equations you can write Bm by Bn is equal to 1 by d square divided by 1 by capital D square, which will be d square by small d square, which will be, according to this equation, 10 raised to 0.4 into n minus m, where n is capital M here. So capital M minus small m. So if you take log on both sides, you will get log Bm by Bn, which will be equal to 0.4 into m minus m. So m minus m will be equal to 1 by 0.4 into log a by b is log a minus log b. So log Bm by Bd, that I can write like this: Bm by Bd is Bm by Bn is d square by small d square, which will be equal to 1 by 0.4 into log capital D by small d all square. So capital M minus small m will be equal to log d square, something square can be written as 2 into log d by d. So it will be 2 by 0.4 into log capital D by d can be written as log a by b is log a minus log b. Now small m minus capital M will be equal to multiplying both sides by negative minus, you will get 2 by 4.4. 2 by 0.4 is 20 by 4, which is 5 into log d minus log small d. But you know that capital M is the representation for the absolute magnitude. If a capital M is absolute magnitude, then this distance d will be 10 pc, the 10 parsec. So put it here, you will get m minus capital M is equal to 5 into log 10 minus log d. Log 10 is 1, so what we will have is m minus m is equal to 5 into 1 minus log d, that is, if you multiply it by minus sign, it will be log small d minus log capital D. So it is small d log 10. So it will be 5 log d minus log 10 is 1, that is into 5 is 5. So we will get an equation like this: m minus m is equal to 5 log d minus 5. This equation here, what we have changed is multiplying both sides by minus m will become small m minus capital M, log d minus log small d become log small d minus log capital D. When small capital M is the absolute magnitude, then capital D will be 10 parsec. So put capital D is equal to 10 here. Then here small m is the apparent magnitude and capital M is the absolute magnitude. So what we will obtain is m minus m is equal to 5 log d minus 5, where small m is the apparent magnitude, capital M is the absolute magnitude, and d is the distance of the star. The quantity m minus m is called the distance modulus, since it depends only on the distance of the star. So this relation is actually the fundamental relation between the apparent magnitude small m and absolute magnitude capital M and the distance of the star measured in parsec. So that's all about the apparent magnitude and absolute magnitude of a star. Now in the next we have to discuss the categories of a star, that we will discuss in the next lecture. Thank you.